Good morning. My name is Vic Nagji. I'm product manager responsible for core technologies. And it's my great pleasure to be here today to spend an hour this morning talking to you about some of the things that we have been working on, some of the big themes that Jord mentioned some of this morning. Three main topics that I will be addressing today is cloud computing, big data, and mobile development, because these are three themes that we see around the world as hot topics. So by all means, please ask me any questions. If you don't have time, if we don't have the time to answer the questions during the presentation, I will be here all day, so we can talk then, or we can talk in the evening, whenever. But please feel free to ask me questions. Okay. So we will start with cloud computing. Again, this is one of many definitions. This is from the National Institute of Security, NIST, Standards and Technologies in the US. And I'm not going to read this definition of cloud computing. But what I'm going to do is I'm going to highlight a few words that I think are important from a cloud computing standpoint. So the words that are highlighted are, the system needs to be on demand. It needs to be made available on demand. You need to have a shared pool of servers. You need to be able to rapidly provision and then also deprovision the systems. And you need to do all of this with minimal amount of management. So if we take these keywords and we apply this as a principle to the cloud, then it becomes clear that we need to be able to take advantage of all of these features. And whatever we do in the cloud, we need to be able to take advantage of those main features. So we'll talk about how we're going to do that. But before we do that, I would like to touch on the main cloud service models. Now, there's actually 5 or 6 cloud service models, but these are the 3 main ones. So software as a service, infrastructure as a service, and platform as a service. These are some general definitions of what each of these are. Our focus is with software as a service. So it's InterSystem's goal to make it easy for you to be able to provide your application, your software as a service, if you so desire, in the cloud using Cache or Ensemble. So we'll look at software as a service today, and if you would like to discuss the others, please feel free to find me later. So I like this picture. This is a picture of a bank vault. This is where you go, and I think we still have these, although it's becoming rarer that people actually use them these days. But this is a bank vault. So what does a bank vault have to do anything with cloud computing? Well, software as a service really can be thought of as a bank. What does a bank do? A bank protects the privacy of all of the customers, so it has many customers. So the bank's responsibility is to take care of all of the assets of these customers, but at the same time protect the privacy of the customer. So customer 1 is not getting data from customer 2's account information. So you don't want to know what your friend has in his account, for example. But the bank is providing a shared service to all of the customers. And this service is very reliable, right? Can you imagine if you go to the ATM and you put in your PIN, your ATM card, and the machine is down, and you're not able to get any cash? You wouldn't be very happy, right? So the point is that a bank provides very highly available and reliable service to these customers. And the last part that the bank does is it provides all of this in a secure fashion, but is highly and massively scalable. So a bank doesn't know when it's going to get new customers, right? Somebody moves to a new town, and you go and you sign up with your local bank. Now you're a new customer. So they need to be able to provide an infrastructure that can scale along with unpredictable demand, okay? So a bank is a very, very good model for good software as a service. So if you can hit these three features, that's when you have really good software as a service. So to summarize the features, the first feature is called multi-tenancy. So for you to provide software as a service, your application needs to be able to conform to multi-tenancy. What does that mean? Basically, this is a picture of an office building, and as you can see, there are many offices in this building. So there are multiple tenants, and that's what multi-tenancy means. It means that you have one server, and you have multiple applications running on that server simultaneously, but the applications are all isolated. So your application to have good software as a service or to provide software as a service, your application needs to be able to run in a multi-tenant environment. Fortunately, we provide already some very good ways for you to run an application in a multi-tenant environment, even on a single instance of cache. You can make different namespaces, you can have different databases, you can have separation of data that way. So first characteristic is multi-tenancy. The second characteristic is, you see the cloud is everywhere, right? And for software as a service, you need to make sure that your application is available to your end users everywhere. So it needs to be accessible either globally or regionally or locally, just depending on where your application users are. But it needs to be highly available, just like that bank story. And the third characteristic is you need to be able to take your application and configure it and customize it very quickly and easily to tailor it specific to the requirements of a given customer, okay? Because not every customer that's going to want to use your application in the cloud is going to want to do the same thing. And you don't want to have to spend a lot of time configuring and reconfiguring your application for each customer. So you want to have a way to very quickly provision this environment, configure the application, tailor it specifically for that customer, and deliver it, right? So we don't want to be a me too. What does that mean? That means that we don't want to simply say InterSystems technologies can run in the cloud. Okay, that's like checking a box. If you get a long list of questions from somebody, do you run in the cloud? Yes, check. So that's like a me too. We want to do something different. We want to actually understand what it is that will help you, and we want to help you get to the point where you need to in terms of actually providing software as a service. So that's what we want to do. We want to help you move and grow and actually take advantage of the cloud by talking to you about what good use cases are, talking to you about when it makes sense to use the cloud, and helping you, giving you the actual technology. Because we can talk, right? You can even go and read online about all of these things. But how does that help you? So we want to actually give you the technology in your hands to be able to very quickly provision environments in the cloud using Cache Ensemble, okay? So how are we doing this? How are we making it easy for you to actually take advantage of the cloud? Last year, I gave a demo of this. I don't know how many of you were in the session that was in Tokyo. Anybody from last year? Anybody attended last year? No. Okay. Nobody saw my demo. I should have done a demo this time too then. Maybe I could show you later this evening. But there's this company called RightScale, and I'm going to talk a little bit about it. Has anybody heard of RightScale? No? Okay. They're making a big appearance now also in the Asia-Pac region, so you'll start to hear from them. Now, RightScale is not a cloud service provider. They don't have servers. They don't provide equipment. What they do is they provide a platform to allow software like Cache and Ensemble to be very easily deployed along with your application in a customized manner out in the cloud. Okay, so it provides basically like a very nice step-by-step roadmap to allow you to be able to take your application that you can set up today on a server and run it in the cloud. Okay, so there are two slides that I borrowed from RightScale from one of their presentations that their cloud architect had done at the Global Summit, at our Global Summit this year. What this slide illustrates is, you know, ignoring the stuff at the top. I'm going to try to use this pointer. Hopefully I don't use it on my own eye. So ignoring the stuff up here for a minute, let's just come down here, okay? So on the left side, you see private clouds. On the right side, you see public clouds. And in public clouds, you see Amazon Web Services, you see Rackspace, Azure, HP Cloud, DataPipe, et cetera. And on the left side, you see all the private cloud options. So VMware, Citrix, CloudStack, EMC, Cisco, et cetera, et cetera. What their whole premise is, that the reason why they are so good at what they do, and that's the reason why we use them, is they've created a model which can span all of these clouds, okay? So essentially, if you create anything in their infrastructure, in their configuration, you can, with a little bit of tweaking, you create it once and you can run it on any of these clouds, okay? And that's huge because that allows you to have the flexibility to then really customize your application and deploy it in any of these clouds that you might choose. So for example, you might choose, okay, now this thing is dead. We're not having a good day with technology today. Set that down. So you might choose to have, you know, Amazon Web Services for your cloud service provider, for example, for one customer. Another customer might come and say, I hate Amazon, and I want to do Windows Azure. So if you have the ability to very quickly and rapidly say, okay, no problem, you know, we can take this, our application, and we can now very quickly deploy it on Azure with minimal work because we're using this particular framework, you know, that's great. Otherwise, you have to sit there and, you know, recreate your application and refigure out how to deploy it, and et cetera, et cetera. Okay, so this slide really gives a good example, a visual picture of all of the clouds, all of the public clouds that are out there, like Amazon and Azure and Rackspace, et cetera. And by looking at this picture, you can see really that the RightScale framework spans all of these clouds, so it provides truly global coverage. So if you create your application, if you create your service, your software as a service offering, using the stuff that we've created within the RightScale framework, which is on that website that I'd mentioned on a previous slide. Yeah, I can go back to it. It's on over there, and you'll get it in your handouts as well. So there's some examples over there on how you can take Cache and Ensemble, and you can take your application and you can tie it all together, and then you can click Go with a single button, answer some questions, and 20 minutes later, you have a fully configured server running with Cache or Ensemble, plus your application out in the cloud. And you can say, I want to do this in Azure, or I want to do this in Amazon Web Services, or I want to do this in Rackspace, no problem, okay? So I encourage you to go and take a look at that. It's a very, very unique offering that we have. So now let's talk about the things that software as a service makes sense for. So there's some things that software as a service makes sense for, and there's some things which are not good to try with software as a service. So if you have a short-term project, like a really good example is, you know, some airlines around the world, like British Airways, for example, around the time of the Olympics, British Airways, just before the Olympics, wanted to launch a very big advertising campaign in the UK, yeah? And they wanted to encourage people, residents of the UK, to purchase tickets with British Airways to go to the various parts of the UK where the Olympics were going to be held. So they wanted to do this big campaign, okay? It's a very short-term project. You know, it was only live for about 4 months, and at the end of 4 months, you know, when the Summer Olympics, or when the Olympics were done, this application went away, right? So this is a great use case, because what they would have had to do traditionally is they would have to go and buy, you know, 5,000 servers, set them all up, just to be able to launch this electronic campaign. But now, using the cloud, they create the application, they fire it up in the cloud, take advantage of all the properties of the cloud, grow as much as they need to, and at the end of the campaign, just shut it off. Done, right? Not out of pocket for anything. So short-term projects, if you have a short-term project, consider using the cloud. If you want to provide your software for evaluation to people, and instead of giving them a CD or a DVD and saying, here, run this installer, and it'll install my application, instead of doing that, you want to just email them a link. And clicking the link, they can answer a few questions, and then immediately they'll get a server configured automatically behind the scenes with your application running. That's a great use case for the cloud, for software as a service. If you have an application that generates a lot of mobile and web access, deploying in the cloud might make good sense for your application. Because the whole premise of mobile and web access is that people are accessing this data from many different places, right? So if people are accessing it from many different places, you might as well not be tied to having your application running in a data center that's located, you know, in one centralized location. Might as well put it in the cloud. It's a good use case for that. This one is really critical. So what does elasticity mean in the context of the cloud? So elasticity really means is you have the ability to grow and shrink. So you grow when you need more capacity, and you shrink when you don't need that capacity. And you only pay for the resources that you use. So if you have a seasonal application, let's say around Christmas time, your online site is very busy because people want to buy lots of presents for their families from your store at Christmas time. At that time, you're going to start to see a peak in usage. But the rest of the year, you don't see that peak. You know, you see some moderate average usage along the year. So in a traditional system, the way you would configure it is you would go out and you would buy a very big server or a group of servers that could manage your peak, right? Because you don't want to disappoint people that are coming in at the peak time by having a slow application. Because they'll come to your site once, and if it's slow or starts crashing, they'll be like, sorry, I'm going somewhere else, right? So you don't want to disappoint them. So you would size for peak. The rest of the year, that's all wasted capacity, right? It's just sitting there in a traditional model. It's just sitting there. Nobody's using it, you know? So if you have this peak and valley type application usage, or let's say we have a great use case. We have a partner that provides software as a service. They are an events management company. So they manage events like this. They provide the software to actually manage events like this. They created the application that uses Ensemble, and this application allows attendees such as yourselves to go on a website on your phone or go on a website and do feedback and ratings for sessions, give some presentation notes, you know, all those sorts of things. So they have a very unique use case because they go to some conferences where there are 50 participants, just like this room, right? They also go to conferences like Apple's conference where there's 5,000 people, right? So they have no idea when they're going to need capacity. So they deploy in the cloud because they can then grow and spin up servers as they need to. If they're going to an Apple event, they'll just spin up those servers and let it run. And when the event's done, they'll spin those servers back down, and they only pay for what they're using at that time. So if you have a large elasticity need, software as a service is very good thing to consider. Okay. And lastly, if you have users, if your users are spread all over the place, right? So if there's some in Tokyo, there's some in Osaka, there's some in Kyoto, there's people all over the place, right? Then software as a service would make sense, because there's no sense in centralizing. Again, like the mobile aspect here, there's no sense in centralizing data access if your users are spread out all over the place, right? So this is a good use case. Now, let's see what it's not a good fit for, because this is also important. If you have all of your users of your application sitting in one building, right, it may not make very good sense for you to go down the route of software as a service, because you might be able to figure out how much capacity you need and then just go buy a server and just run it, okay? If you have very predictable scaling needs, so let's say again your application is running in an environment where you have currently 1,000 users, and you know that every month, on average, there's going to be one new user added, so that's 12 new users per year. That's slow growth, and it's predictable. You know what's going to happen. So you don't need to have the elasticity aspect that we talked about on the previous slide. If you have very confidential and sensitive data, you might decide that you want to have physical control over your data. Okay? This is not about the encryption piece. Everybody can do the encryption piece. This is about actually having physical control of your data. So you might decide that maybe the cloud's not good for me because I need to know that my data is on this machine, on these disks, and I know that if I have to destroy anything, I can pull these disks out and burn them, right? So there's that caliber of data as well. And if you're in an industry where there's some regulations and rules, you might not be able to run your application in the cloud. In the U.S., there's a lot of stuff around healthcare with HIPAA, which basically gives some guidelines. It's a guideline. It's not a requirement. So it gives guidelines on how healthcare information needs to be stored and treated. Based on those guidelines, good application providers follow all of those guidelines, because the government just recently passed what they call the Hitech Act. The Hitech Act actually gives the government now the power to go to an electronic medical record vendor and demand that all of the HIPAA regulations are met. And if not, then they have to pay big fines. Okay? So now they're enacting it. They put in all of these policies in place 5-6 years back and said, this is best practice guidelines. Now they're changing it from that to here are your requirements. And there's some clauses in there that make it very tough for some people to run healthcare applications in the cloud, for example, in the public cloud. Okay? There's always a private cloud option that you can look at. And this last part is something that's also quite important to consider. The platform as a service or infrastructure as a service provider, like Amazon, for example, guarantees a 95% uptime. And they measure that on an annual basis. Okay? So your environment, your application could be down for 3 weeks straight. No access, no application, no nothing. And they would still be within their SLAs. Okay? So they would not be breaking their contract, because they guarantee a very loose 95% availability, and they measure that on an annual basis. So they don't say, like, I'm going to be 95% available measured monthly. They say 95% available measured on an annual basis. So you need to be able to deal with the fact that your application is not running for those 3 weeks. And if you can't deal with that, maybe the public cloud is not a good choice. Okay? So let's talk a little bit about roadmap. We're going to be looking into providing those configuration and deployment tools that I mentioned using the RightScale framework we already have those for Windows, okay? So when you go to that website, you will see that there's what they call server templates, which are basically like recipes. It's just like a list of instructions that we have created to allow you to configure and launch Cache or Ensemble however you want to configure and launch it, okay? So that exists today for Windows. We're working right now on creating a similar set of recipes for Linux. So then you will be able to take and deploy Cache or Ensemble running Linux in Amazon, for example, with just one click. That's the goal, okay? We're going to be adding on more clouds. So as of this month, we have these recipes available for Windows on Amazon EC2, on Rackspace Open Cloud, and on Windows Azure. They're all available today, okay? So you can go out and try this, and you can play around with it and see how you can launch Cache or Ensemble, configure it very quickly with a single click. And then in the future, we're working on some private cloud offerings as well, so to make it easy for you to be able to create your own private cloud and launch Cache or Ensemble with basically a single click. So the idea here is to make it, again, easier for you to be able to quickly customize and launch your application running in the cloud, okay? We're looking a little bit at Red Hat Linux to create some of these recipes for Red Hat Linux. Red Hat has some strange licensing policies. So they don't make it very easy for somebody to run their application in the cloud. So we're considering seeing if we want to make these recipes available as well for this purpose. We're looking at a service where we can provide basically just a service which then you can take and provide to your end users if you want. To say, okay, you're going to run the application in your server, but would you like to subscribe to my backup service? Okay, and the backup happens automatically to the cloud. So there's a bunch of software that gets set up if they say, yes, I want to do the backup service to the cloud. There's a bunch of stuff that gets set up on their environment. You automatically deploy a server in the cloud, and it just backs up magically. Okay, so like we're looking at creating a backup service for the cloud. Another service that's gaining popularity, and people are asking more about this now, is to provide a disaster recovery service in the cloud. So again, you could set this up, and you could go out to your end users and say, you set up your server here, just like you normally would. But I'm going to set up a disaster recovery system, a DR system, over in the cloud. So if something bad happens to your data center, we at least know that we have a copy, a fresh copy, over in the cloud, and we can switch over if needed, okay? So disaster recovery service in the cloud. And this one is a maybe. So these are, again, recipes like cloud templates. So for example, let's say your application, when you deploy your application at a customer site, let's say that the architecture looks something like this. Let's say you have 2 load balancers, you have 3 application servers, you have 2 web servers, and you have 1 database server, okay? And that whole thing is orchestrated together as your application, right? So the users go on the URL, which comes in through the load balancer, goes to the web server, goes to the application server, gets the data from the data server, and then goes all the way back, right? That's an architecture, right? It's pretty common deployment architecture for web applications. A template would be, if I hit the go button, if I say go, I would get all of those systems configured automatically for me in the right sequence, and they would all be connected to each other, and I would get this full deployment that's created with just a single click. So that's what a template is. And the RightScale framework, again, makes it very, very easy to create these templates. So again, I encourage you to go and look at that from that perspective. Big data. So we're going to move on to the topic of big data now. So again, many definitions, and even Jorg brought up some good definitions. The 3 V's. I don't have the 3 V's on my slide, but I need to add them. I will get those slides from you and I will add them. So there's many definitions of big data. I'm not going to read them out. I'll let you read them. Gartner has a definition. McKinsey has a definition. I personally like the definition from Forrester. It's an analytics company that does IT analysis and research and publishes reports and results on various things. So Forrester says big data is not defined by how you can measure data in terms of volumes, velocity, and variety. So it's not the 3 V's that York said. So forget about what York said. But instead, it's the frontier. So it's the most important thing in terms of how you can store, process, and access all of the data that you need to in order to operate effectively, make decisions, and reduce risks, and serve your customers. So it's all about taking action on large volumes of data. So people think about the big data problem from the perspective of, oh my goodness, I have so much data, how am I going to store it? That's the first thing that comes to mind when somebody says, I have a big data problem. But what this is encouraging, and what I'm encouraging you to think about is from the other way around. You say, wow, I have so much data, how am I going to enrich my application? How am I going to take use of this data? How am I going to analyze this data? What am I going to do with it to make life better for my customer? What am I going to do with it to earn more money by making a better application? Those sorts of things. So if you look at it from that perspective, it gets to be a little bit more manageable. So the 3 things that Forrester talks about is you need to be able to store the data, right? Definitely need to be able to store it. So you have to solve that problem. You then need to be able to process it because you're not just archiving the data. You're not just taking it and storing it away, just putting it away. It's not like an archive, right? You actually want to do something with it. So you need to be able to process it. And you need to be able to access it, okay? So you need to be able to process it while you're putting the data in, and you need to be able to access it after the fact to actually do some sort of analysis on it. So these 3 things, I think, make up big data. Or you can use the 3 V's. Doesn't matter. Either way. Okay, I found this slide. You won't be able to read some of the words here because it's kind of small. But I like this graphic. This is a slide from IBM. I'm just going to read out a few things here that give you an idea about what big data really means. The first thing says that there's 2.9 million emails sent every second worldwide. Every second, 2.9 million emails. Okay, I know none of you are sending emails right now because you're all listening to me nicely. There's 1.3 exabytes, not petabytes, not terabytes, exabytes of data sent and received by mobile internet users. That's a lot of data, right? There's 50 million tweets per day at Twitter, right? I think you guys have something similar to Twitter here. Do you use Twitter? Anybody use Twitter? Yeah, okay, great, yeah. I'm on Twitter, so you can follow me. And so this is interesting. This is an interesting slide. It's in the printouts, and you can look at it. But I find it really interesting to think about, how the whole world is evolving now in terms of we have so much data. What can we do with it to make life better? What can we do with it to make our applications better? What can we do with it to make it easier for our customers to use the application? How can we improve the quality of their life on a day-to-day basis? So I'm going to talk a little bit about some technologies that you may have heard of. I'm hoping everybody's heard of cache. That's why you're here. But there's some other technologies and buzzwords that are out there. So I'm going to very quickly put some context behind some of these things, okay? So Hadoop, Mongo, MongoDB, NoSQL, and cache. So let's see. What is Hadoop? Hadoop is free and open source. It does not provide any SQL support, so there's no query capabilities that Hadoop provides. It's a non-transactional system. It's fantastic for batch saves and batch reads. And it's a stream or file-oriented application, basically, is what it is. Okay? It's a distributed, shared nothing, stream or file-based, non-transactional, no SQL approach of computing. Okay? So what's Mongo? So then MongoDB came around. MongoDB is a document-oriented database and a big data solution. Okay? Again, it's a shared nothing thing, but instead of being a stream or file-based solution like Hadoop is, Mongo basically takes advantage of the same architecture to have distributed computing, but it's a document-oriented database. So you can actually put and get documents out of this database. Supports multiple languages, runs in multiple languages. It does sharding. Again, sharding basically means you take a particular piece of data or work, a unit of work, and you distribute it out to multiple systems to actually take advantage of all of these systems that you have running. So that's what sharding is. So it does sharding automatically. It provides a custom query language. It's not SQL. They provide their own version of a query language, which you then implement if you want to actually query the data and get some data out from the system. And it says immature MVCC, which is multi-version concurrency control. So basically, what this means is that if you put enough pressure on this particular model with concurrent accesses, you can start to notice a degradation of the performance, and you can start to notice the degradation of the reliability of the system. It's just not designed for multiple concurrent accesses. It's designed for putting the data very quickly into this sort of an environment. NoSQL, so all of these do NoSQL. So what is NoSQL? NoSQL is basically a term that was invented to say not only SQL. Okay? It does not mean no SQL. It means not only SQL. So the main thing there are gets, puts, and very limited query capability to actually handle what they call key value data, right? So just key value pairs that are stored in these big data solutions, and the keys can be complex keys, composite keys, and the way you interact with this is you say, get me a record that's between this key and that key. Simple. No complicated queries here. NoSQL is free and open source. There's no schema, so there's no definition of an actual schema in this sort of an environment. And there's very simple APIs that are provided. You're all familiar with Cache. This is just a general slide. Cache obviously is a fully transactional database management system. We provide full SQL support. We can do both. We can do very, very quick batch inserts and reads, and we can also do very, very good multi-version concurrency control, because you can actually have multiple users accessing the data at the same time, and you won't run into problems. We provide both NoSQL access, because you can write a quick dollar order to loop over your data. You don't need to use SQL to get the data, or you could use SQL, provided from, it's out of the box. That's what you get. We've been doing key value storage since 30 years, okay? Basically, if you look at a global, what is a global? The data is stored as a key and a value. And the key can be a single integer, or it can be many subscripts, or it can be a composite of many subscripts put together, or it could be whatever you want it to be. And the value can be anything, right? It could be a string, could be an integer, it could be a stream, could be whatever you want it to be. So we've been doing key value storage for a really, really long time. So let's see what we don't do today. So if you go and look at any website about big data, and you look at the features for big data, you will see about 5 or 6 things. Because the approach that they take is they come from, you need to be able to take a problem that comes in and shard it. You need to be able to take a problem and distribute it automatically to multiple systems, do the processing. That's part of the MapReduce framework. Do the processing, get the answer back, okay? So auto sharding. Cache does not provide auto sharding, okay? in a cache environment, you basically have one system, or with ECP, you have multiple systems. The problem comes in, and you handle the problem on that particular system. Whatever the request is, you handle it on that particular system. We don't have a way today to take a message that comes in, for example, and then distribute it out to 50 nodes to have those 50 nodes actually do small parts of the problem and then get the answer back. We don't have those mechanics today. Frankly, we don't have them because we've not needed them, because the industry is really moving in this direction with the large scales of volumes that we're seeing for this data. So this is new ground that we're starting to cover now. We don't have a native MapReduce type implementation, so we don't have a way, again, of taking a problem and distributing it out, not only with the data. Sharding is about the data. MapReduce is about the logic, where you say, I have this piece of work that's come in, and I want to actually send it out to multiple nodes and then collect the answer back. I want to get an aggregate back from all of these nodes. So that's the MapReduce framework. We don't have an implementation for that. Similarly, we don't have an implementation to actually do job scheduling, distribution, and management. So we don't have a way to say, if a problem comes in, keep track of where it's being solved and tell this node to go and solve this part of the problem and that node to go solve that part of the problem. Again, it comes back to the MapReduce implementation. I know I'm speaking quickly. I'm sorry. So truly local and distributed parallel queries. So we have introduced over the years a way to actually run queries in pieces of the queries in parallel on a single system. And we're actually evolving that. We're making it a lot better, okay? But we don't have a way to do distributed parallel queries that says, server 1, you go off and you do this chunk of the select, and server 2, you do this chunk of the select, and server 3, you do this chunk of the select, and we stitch it all together and give you the answer back. We don't have that mechanism, okay? And again, this is part of the MapReduce and auto-sharding capability, where in a Hadoop-like environment, there's a master node. The master node always knows how the data is sharded across this cluster, and always knows where to find the data, and always knows where to send a problem. So it's like a controller. It's like a main system that's sitting there that knows the state of the entire framework. So again, since we don't have an auto-distributed framework, we don't have a controller type environment. Why am I saying all this, right? I'm saying all of this because I want you to be aware that we've been dealing with big data for 30 years, okay? We've been dealing with very large volumes of data for many, many years, Yumatsu-san talked about the European Space Agency. Jörg gave some examples of some of the other application partners that we have in the US that are doing some interesting things, and worldwide, for that matter. We've been dealing with lots of data very long time, okay? We have fantastic tools for you to be able to analyze that data. We have Deep Sea. We have INO. You can unlock the meaning of this data very easily today using our technologies, okay? We don't do all of this stuff simply, honestly, because we don't have a reason to do this stuff yet, okay? Because you can take a lot of this data and you can analyze it very, very easily on a single system using our technologies, frankly, okay? Now, we're not talking about the quantities of data like Google deals with, for example, or Yahoo deals with, for example. In that case, it makes sense to have a very large distributed environment. If you're talking about exabytes of data that you need to deal with on a daily basis, there's not a single system that you can configure to get that big. So then you need to start to get into this particular type of thing. We're looking at all of these features. We're trying to figure out how and if we want to address the fact that we don't have these features. And we'll let you know more. But in the meantime, this is a video on our website. I'm not going to show you this, but you can go to intersystems.com/bigdata. This gentleman up here is a colleague of mine, Aaron Hutchinson. He's responsible for big data. You can send me emails, and I can answer them, and I can involve him as well if you have any questions on big data. Mobile. Everybody still with me? Everybody seems to be awake. That's great. Good. So what is a modern mobile application? So we're switching gears now. We talked about cloud, we talked about big data. Now let's just focus a little bit on mobile, and then we can all go have lunch. So what makes up a mobile application, a modern mobile application? If you want to provide a good mobile application and you want to have success, you probably need to have it be able to run on all devices out there. And fortunately, there's like 3 major devices, right? There's iPhones and iOS, Android, and Windows Phone, right? There's BlackBerry also, but we don't talk about that. Yeah, they still exist. They're still out there. So, okay, you need to be able to create a client UI. So this user interface needs to be able to run on a mobile device, so a tablet or a phone, for example. You need to figure out how to solve the problem of data transfer, okay? Because that's a big thing. So you want to minimize the amount of data that you're transferring to and from the mobile device because you don't want to exceed somebody's plan. I don't know how your plans work here, but in the US, plan that I have is a 5 gigabyte per month mobile plan, okay? And it's a family plan. So my wife's iPhone and my iPhone are on the same plan, okay? So if I go over that 5 gigabytes in a month, 5 gigabytes is a lot, by the way. If I go over that 5 gigabytes a month, then I get charged for every gigabyte, I get charged lots of money, like $20, $30 or something crazy like that, okay? So when somebody writes a mobile application, you want to make sure that the data transport is very, very slim and very optimized so that you're not sending across, a 10 megabyte document every time you're actually making a request back to the server because you very quickly exceed somebody's capacity, right? So you got to solve this data transport problem. It's got to be thin, it's got to be efficient, and it's got to be quick. You need to have somewhere to put the business logic, right? So there's some business logic that you're going to implement in your application. And you need to figure out where that's going to go and what makes sense. So we'll take a look at that as well. You have to store the data, right? You have an application, and you need to be able to store the data somewhere. You're not going to store it on the phone. You have to be able to store it in a reliable place where you can actually get access to it after the fact. And you need to be able to provide some form of reporting on the mobile platform, okay? So these are the main characteristics of a modern mobile application. Now we're going to take a look very quickly, since we're running short on time, we're going to take a look very quickly on how you can address each of these things, okay? So let's first look at some of the modern UI options, and I'm going to go a little bit quickly on these slides. So you could create something to run natively on a platform. So you could use Xcode to create an application to run on iOS, to run on Apple's ecosystem, right? You could create a Java application to run on Android, or you could create a .NET application to run on Windows, okay? Again, see, no BlackBerry here. There are third-party JavaScript libraries. There's third-party JavaScript vendors out there, Dojo, jQuery, Sencha, there's a whole bunch of others that you can use to create your application, okay? Or you can, we provide some stuff that allows you to very quickly and easily create mobile applications, okay? And we'll touch on some of these towards the end of the slide. But essentially, we provide this thing called Xenmobile Framework, which is actually new. It was demonstrated over in Global Summit earlier this year. We're hoping to get it included in the product very shortly. And then there's this thing called Xenmobile, and then there's this thing called Zen. We love to use the word Zen, so we put it in wherever we can. All of these have some characteristics in common, okay? All of them can do things like HTML5, they can do cascading style sheets, they can do JavaScript, and they can do SVG for rendering, okay? So that's the key. You need to be able to find a technology that can do all of these things, okay? And basically, this slide shows many different ways to do it. If you just want to do an iOS application, you could create a native iOS application. Or you could use one of our technologies and run it on the iOS device and run it on the Android, and run it on Windows Phone, right? Okay, so some of the challenges that we talked about. We already talked about moving data. You need to make sure that you move the data quickly and efficiently, and you also minimize the amount of data that you're transferring to and from the mobile device. Processing data. So are you going to do the processing on the phone? And how much processing are you going to do on the phone? Because, again, a mobile device has some very scarce resources. Battery life on a mobile device can be used up very quickly if you have an application that's running, doing a lot of processing, right? So it's not designed for very heavy processing. So you need to make sure that you minimize the amount of data processing that you actually do on the device, and instead do all of the processing somewhere else, and we'll take a look at where. Your application needs to be able to provide customized information. So this needs to be something that is customized for each and every user. So they need to be able to say, oh, I want to make my application look like this, and I want a green thing, or I want a red thing, or whatever it is, right? And they need to be able to configure it and customize it. And you need to be able to provide the data or the information in a just-in-time fashion. So if somebody goes to your application on a mobile device and clicks a button, and they're sitting there staring at the thing just turn, not going to use your application. It's got to be fast. It's got to be just in time. All of these platforms now provide this thing called push notifications, right? So if there's a thing you want to make your user aware of, you can take advantage of the push notification. So that's really just in time. Like I subscribe to the New York Times, the Wall Street Journal, and CNN application on my iPhone. Okay? If there's some breaking news, it sends me a push notification that says, hey, click here to read this article of this breaking news, something big's going on somewhere, right? That's a push notification. That's just in time. That's out there, okay? Okay, we're going to talk briefly about some of these technologies. You may or may not be familiar with them. These have existed for quite a while. Now we're going to be talking about sort of how you get the data to the device, okay? So one way to do it is to use XML or AJAX, right? And XML HTTP has been the standard on the desktop. It actually led to the Web 2.0 revolution, and revolution is in quotes here. And essentially what it turned out to be was simply SOAP over HTTP, very lightweight way of doing it. You can use SSL for encryption at both ends, and it's available on all the browsers. So basically you can just do SOAP over XML if you're running your application in a browser and just call it a day. Still a major player today. Okay, so some people use it. It's going to continue to stay. Who came to challenge AJAX? Jason did. These sound like names of people, right? So Jason provides a sparse array structure, which is very, very good because now you can actually take and process and analyze the data quickly because it's a sparse array. So you can index into the array and you can do stuff like that. There's no markup associated with this. It's not bloated like XML. So tastes great and it's less filling. So you can send smaller messages to and from the device and deal with parsing smaller messages because there's no XML markup associated with it. There's no predefined structures, which could be a good thing or a bad thing. Does late binding, which is great. There's less overhead, and you don't have to spend too much time parsing it. It's very, very easy to parse this data. And this, Jason has already won the war on mobile devices. It actually is now becoming the de facto standard on mobile devices. Okay? And then there's SOAP versus REST. So we'll touch on REST a little bit towards the end of this. But SOAP essentially is available, you know, if you want to use SOAP, that's fine. If you want to embed your application in a browser. And REST, you know, REST-based applications are also making a big appearance now. You can run JSON natively on it as a simple call structure. You can do get, post, delete, and put. Basically is what REST defines. It's a URI. You can say get patient ID X or get student ID Y. There's no WSDL associated with it, and there's no requirement for any interface mappings to be created ahead of time. For mobile today, the trend that we're seeing is people are more and more preferring JSON rather than going the REST route. But that's just a trend that we're seeing today. That may change in the future. So in all of this, where do you put the logic? 5 minutes, okay, thank you. So it's very important to put the logic in a place where you can actually do some good processing, okay? So the interfaces on a mobile device are very, very simple. They're designed to be they're designed to provide containers to be able to display your application and display your data to the end user, okay? So the logic layer has to be broader and smarter. You might consider putting in an enterprise service bus, which executes all of the logic and then generates the data and sends it out. And guess what? Ensemble and Healthcare Foundation provide a fantastic enterprise service bus functionality. So, that's a shameless plug a little bit for Ensemble. Go use it, it's great. And another option is to look at Zen, where you actually, using Zen, using our technologies, you can actually do server-side portion. In the server-side portion of the page, you can do all of your execution that runs on the server, and then get your answer or get whatever you want to display, send it back to the mobile device, and off you go. So where do you put the data, right? So that was another question. Well, clearly you could put it in cache, which would be our preference, but you have other options, right? You could pick one of the cloud-based databases that are out there. If you want to deploy in the cloud and not use cache for some reason, and you want to just use cache for the rendering piece and the application piece, there's other options out there. You could pick a relational database or a cloud-based database, a NoSQL database, key value pair. But again, our preference is use cache, please. And then from a reporting standpoint, you can embed BI into your mobile application, and you really should, and provide real-time access to the users. So this CAN and ad hoc reports. So CAN reports would be something like, for example, if you want to provide a report of sales activity to somebody to review, okay? You could create a job on the server to summarize the sales activity from yesterday and create a PDF document. And you could ship that PDF document off to the mobile device and render the PDF document there. So that would be like a CAN report, so it's out of the CAN, right? Ad hoc reports are more like, oh, now I want to look and see for this one product why my sales were lower. So now that I'm going to do an ad hoc report query that says, for yesterday, show me the sales and show me the patterns and those sorts of things. And it needs to be able to run on all of my devices. So I have an iPhone, I have my Mac, and I have an iPad. Okay. So when I use a mobile application, I expect it to run on my iPhone and my iPad seamlessly. Okay. So very quickly, how does this all relate to InterSystems? We do, like I said, we like the word Zen. So application called Zen. Xenmobile Framework is a new one, as I was mentioning. We have full JSON support. We've started introducing REST, and we have Zen reports for you to be able to do mobile reports. Okay. Very quickly, I'm going to go through this. Mobile Zen solutions, you have a %Zen component mobile page class that you can actually inherit from. And this allows you to take your existing CSP pages and actually make them friendly for mobile. So we try to make it easy for you to take your application and create a mobile version of your application, okay? And you can do all these sorts of things. You can set up your orientation and geometry, et cetera, et cetera. Xenmobile Framework is new. This is for new applications and is designed from the ground up specifically for mobile. It's fully driven by JSON. It's fully rendered on the client, which is great, which means that you don't have to render the image or the document on the server and send that big document over to the client. You can just send in, JSON, and you have the sparse array, and then it gets entirely ingested and rendered on the client itself. And the components are fully optimized for mobile, so there's like specific components and widgets that you can use part of this framework. If you really have to go native, we provide Xenmobile, which actually gives you hardware access. It gives you access to be able to do things with images, gives you access to be able to do barcode scanning. And we've created JavaScript wrappers for common native APIs. So we actually have a JavaScript wrapper for iOS. We have a JavaScript wrapper for some Android functions in Xenmobile. And it's driven by ZMF and XenUI. And we have robust JSON support. So you can do JSON with Xen, or you can do JSON outside of Xen. And we have APIs for both. So within Xen, we have a whole bunch of providers that you can go read about. And then we also have persistent JSON, which is offered by NoSQL access. In 2013.2, we're introducing REST, which is actually really cool because what we can do now while introducing REST is actually support the URI aspect to get and set data, but we can also do things like URL manipulation for navigation. So your application can then, instead of the passing of explicit values, your applications can just say, I want to open up patient 1235, and the URL itself gives you the meaning of what you need to do. So it's part of the REST-based architecture. Okay.